Okay, everybody, this is all a bit weird, but apparently you're all out there in big numbers. But I'm in here at the MAV with two people, but apparently there's 300 odd of you out there. So Helen's done the introduction. That was fantastic. It should have been. I wrote it myself. So anyway, all the background is there. Um, this is my first session for a while. Actually, been out of action because of the old My Sharona. So this is my first session for about a month. So the topic for tonight is open-ended maths activities. So that's what I thought I'd do. And as usual, anybody who's been to my sessions, I think it's got to be hands-on. Um, and I think through that, my philosophy will come through anyway. So I've just picked, I don't know if we'll get through them all, but I've picked 4 or 5 open-ended activities. I've also chucked in an open-ended maths problem. It's probably a good question to ask. What's the difference between an open-ended problem and an open-ended activity? For me, my working difference is that an open-ended problem normally is accompanied by the problem-solving strategies like draw a diagram, solve a simpler problem, make a table, and so on. So anyway, you'll see that with the activity I've got for you today. It's targeted at the 5 to 8 area, so well, it's really most of the activities you can do from year 3 to year 10 because otherwise they wouldn't be that open if you couldn't actually open them all up. So um, open-ended activities and problems, I just think they're one of your gifts in teaching because you don't have to come up with 3 different activities for 3 different groups, which is often just 3 different worksheets in a lot of cases, sadly. But when you can just do one activity, you work hard enough as teachers, and you certainly have been during the whole sort of pandemic. But so I think the more times you can go home and think of one activity that's going to cover all your kids, that's just good for you. It's good for your kids because there's no self-esteem issues now. They're all doing the same activity. They can all look around, and all of you are doing the same activity, and that's got to be good. And a lot of cases, that's you can have another glass of red and watch Bachelor in Paradise, which I'm really excited about. Can't wait for it to start. Anyway, let's let's. I know it's sad, but let's get into the first activity. Um, I'm often asked to sort of demo lessons on fractions, decimals, and percentages. So this is an activity. I don't know, with the 300 of you out there, a few of you must have seen this one, I reckon. But it's just one that I love. It's one because in a lesson you can turn a kid around from being quite scared or anxious about fractions, decimals, percentages, which, by the way, are no big deal. They're just stuff smaller than 1. And you can turn them around and just have them feeling really confident about it. So that's why I'm a big fan of this activity. So I'm going to switch to another camera here just to show you the layout of the activity. Right, if Danny Analyst taught me how to do this properly. Here we go. All right, so this is an activity. It's called Get Me to One. By the way, we're sending out all of this stuff. I've left it with Helen, and I think she's going to put it on Google Docs or something. But you'll be able to access all these activities and they're presented here. But what you have to do is I've got 26 cards here. I know that because it starts at A and it goes to Z, so that'll be 26. What you need to do is you need to put pairs or more of cards together so that they equal 1 exactly. The activity is called Get Me to One for a reason. So uh, the rules for the game are simple, or it's not a game, it's an activity, that you need to get to 1 exactly. If you use 2 cards to get to 1, you get 2 points. If you use 3 cards to get to 1, you get 3 points. 4 cards get you 4 points. It goes on like that. There is a bonus if you can put a fraction and a decimal and a percentage together in the same equation. You get a 1-point bonus. There's also some cards. I'm going to mark them with just a a blue dot next to them, that if you use these ones, I'll actually give you a bonus point. Like I'll give you, if you use h in an equation, which is 0.125, I'll give you a bonus point. If you use 2/5, I'll give you a bonus point. If you use 3/8, I'll give you a bonus point. 3/5 anywhere in your equation will get you a bonus point. Yeah, I think that'll do. That'll do. So that's how it works, kids. You've got to put together an equation that gets to 1 exactly. Think about this as like a meter. You're trying to get to 1 meter, and 3/4 of a meter. The one up here, B, might be like, oh, what's 3/4 of a meter? Oh man, that's 75 centimeters. I only need 25 centimeters more. So which one of these ones of the cards is equal to 25 centimeters? There's actually 3 of them, kids. So you can use two. You can use 2 cards there. It'll get you to 1. Like I said, use 3 cards, 3 points. You cannot repeat a card. Like have a look at K. K is a half. But you can't go K plus K. That's no good. No, can't do that. But you can use K again in your next one. I'm going to get into it's what us teachers call kid demo. I'll get a demo from somebody out there who's tuned in at the moment, and I'll put that one down, and then you guys can get going from there. Is there anybody out there who has seen a combination that can get me to 1 exactly? Somebody's showing off. H plus S plus, what was that, Danielle? Plus O plus V. I know. H is 0.125. This is a big score if this one works out. S is 3/8. Well done to that person. That's nice bit of conversion. Hold on. I've just got to check this one out from the HSOV person. 0.125 and 3/8. Beautiful pickup, because 0.125 is in fact an eighth. So we've got 1/8 plus 3/8. That's 4/8, which we can make simples like the
Rob, you've muted yourself, mate.
Right. Thank you. Sorry, don't know how I managed that. I was just saying that Tommy Moore, who put that one in with the H, the S, the O, and the V, that was very nice. 4 cards, 3 of which were bonus cards. That's a 7-pointer. 7-pointer. Oh, yes, like a very good effort. Normally with the kids, that's not the sort of one I get first. I get one from the kids, and it might be B, which is 3/4, plus R, which is 0.25. So I'll put that one up on the board, and I tell the kids, there's a 2-point card. You can all borrow that one, but your tally that you need to get is 15 points. So one of the things with an open-ended activities, kids often, they need a target, because really you can just keep going forever. When do I stop this? So for a lot of open-ended activities, I either set a time limit or I set a target score, and I vary that as I walk around, because I'll see some kid who's going to get 15 points in 3 or 4 equations. So I'll just say, I do it quietly. I just say, okay, dude, I want you to get 30 points. Or I'll say, if in every one of your equations, you have to have one of the hashed numbers or one of the dot numbers. So I set individual challenges as I go around. It's very easy to work this activity up. Yeah, very easy. One of the things I love doing is if a kid's going really well, and I'll say, okay, what's your name? And she might, oh, Stephanie. Okay, Stephanie, you got to make Stephanie equal 1. So what? Yes, you got to use 3/8, which is the S, the T for Stephanie, that's a 2/10. You got to use your E, you got to make your name get to 1 point exactly, to get to 1 exactly. So it's easy to work it up, and it's easy to work it down, because I just get myself next to some of the struggling kids, and they say, oh, I don't know what to do, Mr. V. And I just said, okay, pick one. And they go, okay, I'm picking 7/10. I said, righto. And I get out the meter ruler, which you can see some of here in the screen, and I get out the meter ruler. I said, well, where's 1/10? And they go, well, all right, either with my help or not, we get to 10 centimetres. And I said, well, okay, what's 2/10? And they go, 20. I go, yeah. Where's 7/10? And they go, is that 70? And I said, yep. So how far to go? And they'll say, oh, that's 10, 20, 30 centimetres. So I said, okay, which one of these smells like 30 centimetres? And they go, okay, well, I don't have a 30. Actually, sometimes I do. They go, well, there's 25. And I said, right, we're up to 95. Now, what, got 5 to go. Which one looks like a 5? So they might go A. And I said, nice try, but A is 50 because it's 5/10. It's like what you were saying before when we had 7/10. And they go, oh, is it L? And I said, yes, it is L. So, and it doesn't take long, but to have a meter ruler there with you, oh my God, it makes a difference, just so a kid can visualise what this task is about. And I know some of you with your year 8s, you'll need that meter ruler. I get these fold-up ones. So they're easy to carry around with you. You can get them at Bunnings. They're cheaper, but they're only in millimetres. They don't have centimetres on them, and it's probably for school. These aren't bad. I get them from Modern Teaching Aids. I'm sure I'm paying too much, but so that's your activity called Get Me to 1. It's like I said, I love it. It's so open. You can make it that as easy for yourself. If you're a struggler, you can go A and K, which is 0.5 plus a half. That's going to get you to 1. A little tip for you as teachers: make sure the kids draw the letter and draw the card, because if they just put A plus L plus Q, you're forever looking back up at the board and getting yourself a headache, and it's actually taking up time. So when they're recording their equations in their books or on their computers, make sure they have the letter and the card. It just makes life easier for you. And they should finish it as an equation that it equals 1. You're allowed to go over 1 and subtract. I've had kids who multiply and actually know what they're doing when they multiply a couple of fractions together. It's just, and then I've had other kids who, like I said, are putting things together like 10% and 90%, but at least they realise 100% is 1, gets you there. They might put together 0.5 and 50%, or then they're pretty basic. My job is then to push them on as I'm wandering around the kids and say, hey, try a quarter. What do you know about that? How many centimetres would it be on a metre ruler? 25, okay? So you need 75 more. Where is that one? So, yeah, it gives you great opportunities to get amongst your kid and do that teaching at the point of need. Yeah, I love it. I really love this activity. Just like I said, to see so many kids gain confidence from that who had none going into a unit of work, especially in your area, for you guys out there who are 5 to 8 teachers, just a winner, just a winner. Virtually every time I do this activity, and I have to stop it because I do a share reflection at the end, the kids, oh, yeah, give us another minute, Mr. V. When I've got another one, check mine. Can you see? Come and have a look at mine. It's a good vibe in your room. You're very busy, but that's okay, I think. So that's Get Me to 1. Any questions or comments coming in, Daniela?
Rob, I might just say that you've got heaps of different solutions coming in. So many people. We can get through them all. I think we just move on to the next activity.
Good suggestion. We need someone to just
whoever made that comment, that was very, very good comment. Whoever made the comment that this would really suit kids working in mixed ability groups and learning from one another, absolutely right. Top comment. Yep, agree entirely. It's when you have this activity going in your room, you will get kids who will just they'll feed off one another, and other kids just want to put their head down and work alone. That's what I like about this stuff. It's open. It's open in so many ways. The more open-ended activities and problems you do with kids, the better the vibe is in your room. It's good for kids. Like I said, no self-esteem issues. And this openness encourages kids to talk, to compare, to look at each other's work. It's a good thing, a very good thing. Anything else?
And there's a question here that someone said, have you ever used with different things on the cards? Maybe make 100 with different numbers. Could that work?
Yeah, it's got so many variations. In prep, I'm about to show you one. So whoever had that question is a good one. In prep, I do get me to 10. And on the cards, I've got words like 5, or I might have the numeral 7, or I might have a diagram of 3. I'll have a picture of a triangle. I'll have an array. I'll have a tens frame with 8 dots in it. And the kids have to put cards together to get to 10. So it goes way back. Then you can make it get me to 2 and put in some mixed numbers and some, like decimals, like 1.675 or whatever. So it has a lot of flexibility. The spirit of it is in this next little activity that I'll show you, which is just good for it's good for all the operations and others. But I'll just switch back to the other camera so I can show you this activity. Yep. And so this one is, like I said, it's just the same but different. It's get me to 1,000. So all the operations are up for grabs. You can add, you can subtract, you can multiply, and you can divide. You can actually do other stuff if you want to, by the way. So the objective of the game is to get to 1,000 exactly. There's lots of numbers up for grabs. If you're using addition or subtraction to get there, that's fine. That'll get you a point. If you're using multiplication or division to get there, look, I'll tell you what, I'll double that. I'll give you 2 points. Also, if you use any of the underlying numbers, I've got ones like, I don't know if you can see, there's a bit of glare on that, but there's 11.5. I've got -10 over here, 0.5, 50 1/4, 8.75, 13.5, 0.125. They are the big numbers. We're talking bonus numbers there. But you have to get to 1,000. So once again, I'd probably set a point score. Like in the end, I never compare kids' points. Like it's a personal thing. It's not who didn't get, hands up if you got this many points, who's got the most points. I never do it. It's become, I want a personal target. So I'll set a target because they've got something to aim for. But so often they go over it, or a kid might fall under it. But I never publicly talk about the points. But it's good to have a target up there. So, like I said, all operations are up for grabs. Like you have to get to 1,000. I've given you, teasingly, in the bottom right-hand corner, I've given you 1,001. But I haven't given you a 1. Nah, bad luck. I've given you 1,002. Oh, so close. And actually, I have given you a 2, if you can find it there. So I've given you that one, so that's pretty easy. But otherwise, you need to put together an equation. If you want to do something before something else, kids, use a bracket. That's why we have brackets. They're the big boss of maths. They're the big cheese. They're the big kahuna. They're the numero uno of maths. If you want to do something before something else, you whack it in a bracket. You get to say whack it in a bracket as well, which is, how good is that? So whack it in a bracket if you want to do something before something else. I don't know. Well, let's take one from anybody out there and who's already seen one. If you can see that, okay. There's some great. Sorry, I meant to put a red line under the one at the bottom. 8,864. If you can sort of. If you want to go with that one, that's also a good number to have somewhere in your equation. But you need to get me to 1. To 1 to 1,000 this time. So it's like I said, it's a variation on the other one. This is all I've got this for you, ready to go if you want to use this one at school. So don't bother copying down all the bloody numbers if you're sitting there at home doing that. But it's all there, ready to go. All right. Anybody coming in with one? Righto.
250 multiplied by 4.
Oh yeah, nice. 250 multiplied by 4. It's a double because you've got 250. Double that is 500. Double it again, which is multiplying by 4. Double, and it's nothing better than saying double, unless you say double. But if I think I've got 125 there, maybe I haven't. Oh, yes, that's a double. So 125 by 8, good one. 4 times 250 is 1,000. And so, of course, because I've halved one number, 250, and doubled the other one, the 4. So that's got to be 1,000. Love that. They're all 2 pointers, 2 points for each of those.
What about this one, Rob? You've got a million square root of it.
No, 100,000.
Was it 100,000? Sorry. 100,000 divided by 100.
Oh. Square root of a it is a million. Yeah, so it is a million. So there it is there.
Oh.
Yeah, so the square root of a million divided by 103. Is that what well, just we're going fact check on that one.
I'm fact checking.
The 1,001 minus 1,000 divided by 25. Oh yeah, good. Yeah, I like that one. Yeah, so that's from Evans. Yeah, that was cool. 3 minus 2 plus 999. Thanks, Joel. Yeah, liking that. 10 cubed. I've got the 10 there. Oh, hold on. 10 by 10 by 10.
We have got 10 cubed.
Oh, there it is. Yeah, somebody spotted the 10 cubed. Who was that? Alicia. Is it? Is it from Grace? But Grace, well done. Yes, 10 cubed was already there for 1,000. 10 times 10 times 10.
That was square root of a million divided by 10 cubed.
Yeah, I got it.
By 103.
Yeah, by 10 cubed. We couldn't work out the 103 thing, so now we understand it. So it was divided by 10 cubed. Beautiful work. Once again, even you guys out there, you can tell that some of you, oh man, all right, I'm right into this. I'm going to get into that 8.75, or I'm going to get into that 10 cubed. That you're feeling ready for that challenge. Your maths is up to that, and I've got others out there with some of the ones that are coming in. Don't hear this the wrong way, but it's at a different level. That's what makes it open. That you should all come in at a level that suits you. My job as a teacher is to walk around, encourage, support, challenge you to try something else or to help you out. And it's once again, it's this beautiful opportunities to do your teaching at the point of need. I sometimes get so upset by this word, that term, explicit teaching. My God, it drives me mental. It drives me friggin' mental. Explicit teaching is not you up the front telling kids what you know. Explicit teaching is at its most powerful when it's one-on-one, you with another human being. 10 seconds, 30 seconds, a minute, move on. Then if you have to stop the whole grade because everybody's buggering up how to use square root or something, and you're noticing what brackets they're misusing them as common in middle primary, upper primary, then stop the kids and do a bit of up the front explicit teaching. But don't narrow your definition of explicit teaching to that being you at the front. That's not. It's one and probably the worst example of explicit teaching. Great explicit teaching is you one-on-one with your kids giving immediate feedback. And open-ended activities like this one, they're just a gem for it. The only suggestion I'd have with this one is you probably won't get around to all the kids. They are that keen to have you work with them, and you'll see things as you go around. Just say, I need 2 minutes with this kid, or I need a minute with this kid. Or you might find a small group who are all making the same, all have the same misconception. Pull them for 3 or 4 minutes, let them go back. I'd do this activity again the next day. You might even change a couple of numbers just for the sake of it. Really, I've just made these up as I've gone, and do it again the next day and get to the kids that you didn't get to the first time you took the session. But it's get me to 1,000. A lot of fun, and yeah, just easy to cater for the range of abilities. There's very basic ways to get to 1,000 there, and there's some very, very complex ways. It's up to you. Set a target. The kids will go for that target. They're sucked in by it every time. They love a target. So that's get me to 1,000. Danielle, is there any questions coming in about that or anything anybody wants to know?
People are loving it. That's all.
Oh, lovely. Great.
Brilliant.
Oh, shucks. I'll just get back to WenCab so you can. Here we are. All right, so that's yeah. I guess if they're open enough, that's the point. They're not hard. And if any of these were too complex, you guys wouldn't do them out there. Like I say, you're too busy to be looking around for a lot of things. So this is all available to you at the end of the session. Yeah, please use them. And there's a booklet that I'm also just I don't know. I'd like you to access. It's got 100 activities in it, and it's written for years 5 to 8. I did some 4 days of PD in the western suburbs back at the 2009, 10, 11, and somebody in the crowd took notes on every one of the lessons. So and they were really good. So Christine Tipping, she typed them all up, and it was just a result of 4 days of 4 full days of PD. And there's 100 lessons that I wasn't counting them, but apparently there's 100 lessons over those 4 days, and that's in a booklet now. So I'm making that available to you guys. So it's got some of the activities we're doing tonight in there as well. But yeah, please access those and enjoy them. All right, next little activity. I thought we'd just chuck in an open-ended problem, just so you can just get a sense of the difference. This is one of my little favourites. It comes with a story, so it's you don't have to tell a story, but I tell the kids about my Uncle Jack. So, and by the way, even though most of you are in the year 5 to 8 range as teachers, everybody loves a story. If I'm taking year 10 class, or they still love a story. Preps, of course, they love a story, but so do year 10s. So I tell them about my Uncle Jack, who was, my favourite uncle. He was a great guy. Loved my Uncle Jack. Weird dude. That's okay. Everybody's got a weird uncle in their family. Like everybody, it's compulsory. You have to have a weird uncle. So I tell them about my weird Uncle Jack, and who I liked a lot. And but anyway, he died, which is very sad, very, very sad, particularly for Uncle Jack. But it was sad for all of us. And Uncle Jack left me 60 square metres of land. Yeah, boys and girls, it's not a great size, but that was so nice of him. It's probably half a standard classroom, but over 2/3 of a standard classroom. So it's good of him. It was real lovely of him. But he lived in Queensland for a lot of his life, and that's where he died, and he left me the land. I hadn't seen it. So what I want you guys to do today is come up with a block of land. Actually going to come up with more than one. I haven't seen this block of land, so what might it look like? I know that it's got an area of 60 square metres. Now, if I were you, I wouldn't presume that everybody, just because you mentioned it now, knows the difference between area and perimeter. I'd just still double check. And my way of saying it is just, look, he left me the land. He didn't leave me a fence. So it's not perimeter. He didn't leave me the fence that goes around his land. He left me the actual land that's inside of the fence. So sometimes kids go, well, that's a quick way to know the difference between area and perimeter. Yeah, perimeter's the fence. Area is the stuff you walk on. So kids, 60 square metres of land, you need to show me what that block of land could look like. Before we go on, though, boys and girls, you're going to come up with 5. I'd recommend 5 for year 5s to 8s. You're going to come up with 5 diagrams of blocks. But I'm telling you right now, only 60% of your diagrams are allowed to be rectangles. like my Uncle Jack. It could be a rectangle of land he left me, but he was a different sort of dude, my Uncle Jack. So maybe, just maybe, it wasn't just a straightforward rectangle. And in the spirit of that, kids, only 60% of your 5 diagrams are allowed to be rectangles. Now, you can draw a diagram, obviously. You can just do a rough one in your books. In the end, you're all going to present me with a diagram on some 5mm graph paper, or you can use your gridded maths books, and they've got to look pretty schmick. But you might just get things started by going, oh, yeah, this side could be 6 meters, so this side could be this many meters, and see if that equals 60 square meters. You might want to write an equation. You actually might use the formula for area, length by width. So you might go, oh, look, at one side could be 12 metres, and the other side could be this many metres, that's 60 metres. Yeah, beautiful. So write some equations. And then later, you'll need to turn those equations into diagrams. But that's how you can start. Make a model. Like I know possibly with year 7 and 8 teachers out there that no, we don't make a model. Well, yeah, some kids do need to touch a problem. It's just kids. It's just humans. Sometimes we don't understand a problem until we've actually touched it. So I'd just get some square tiles, or counters will do. But so a kid can picture, like visualize it. Like this kid started off doing rows of 6, and maybe he's going to do 10 rows. He or she's going to do 10 rows of 6, and then they go, oh right, I've got this now, and that helps a lot. Like there's kinesthetic people who don't actually really fully understand a problem until they touch it. So make sure materials are available all the time. If I don't know, I wouldn't limit this just to primary, but if the problem is too difficult for some kids, they just need to start with a simpler problem. So take it back to 30 square meters. I've had kids who I had to take it back to 12, and then they either go straight back to the 60 meters or they go to the 30 meters. But they get it by doing a simpler problem. It's one of the genuine problem-solving strategies. You can guess and check. So you might go, 8 meters times 8 meters. 8 eighths. Oh, that's like that's a square. That's 64. Oh, it's got to be 60. Hey, but I'm close. So the crucial thing with kids to understand about guess and check, it's not guess and you're wrong. No, it's guess and check it and learn from it. You know, the guess doesn't have to be right. It's a point that wouldn't be a guess. So they're allowed to guess and they go, hey, I'm not far off here. How do I get that to 64? What if it 8 sevens? That's 50. Oh, what if I make that 10? And so they start, and often a guess and check is just a foot in the door to get them going. Or you can use the problem-solving strategy of make a table, which I think you can see there. So it's just, I think you'd only need 3 columns for this: length, width, and area. Kids will happily fill in there. They'll come up with 5, 6 more, but in the end, they've got to turn them into a diagram, because the final presentation for this problem is it needs to be a diagram. I really encourage the kids to be creative. Remember, and that's why I put in that only 60% of their 5 diagrams, which I make them work out. So only 3 out of their 5 diagrams are allowed to be rectangles, and that just pushes the kids into, right, I'm going to try a triangle. I've had kids regularly discover half base by height because they want to make a triangle. So then they make a rectangle that's 120 square meters, and then they just go diagonal to diagonal. But I let them, I might scaffold that if I have to, but I'll let them discover it. I've had, I don't know, dozen kids who've wanted to go for a circle of land, or kids going, Mr. B, give me a challenge. And they go, okay, he left me a circle of land. He was a weird dude. He left me a circle of land. Go and prove that it's 60 square meters, and get them onto pi. It's fantastic. A kid I was working with at Solway Primary School in Ashburton, he absolutely determined to have a square of land. So he realised 7 sevens will get me 49 square meters, 8 eighths will get me 64. So it's got to lie somewhere in between those two. So and he ended up getting it to 10,000th of a decimal point to get it to 60, that a square could be 60 square meters. What's that? Is that a surd? With something a near square? Is that a surd? Something that's a near square, Helen? Yeah. Just musing. So it's but yeah, yeah. Well, it says this kid got it to that close. Anyway, it was amazing, but just sheer determination and appropriate use of a calculator just kept on getting it. So he ended up at 59.000. It was a great effort. So that's an open-ended problem. Thoroughly enjoy that one. Look, if you need to bump it up to 120 square meters, I don't think it make much of a difference really, but it's just a lovely open-ended problem. And the key to it, though, is that 5 diagrams and only 60% of them are allowed to be rectangles, because kids will come up pretty quick with 6 meters by 10 meters, 3 meters by 20, and so on. And particularly for, I don't know, for all your 5, 6s and the 7, 8s who are out there, I finished the activity after they've done their 5 diagrams. This takes a full hour. If you've got 100 minutes for it, it's brilliant. They then have to put a fence around their designs, and they have to work out which one of their designs, of their 5 designs, is the cheapest to put a fence around, because there's a law in Queensland, wouldn't you know it, that any bit of property that has an area more than 59 square metres, you have to put a fence around. And if fencing costs $15 a metre, which one of your designs is the cheapest to put a fence around? It's just amazing the number of really bright kids who go, well, they're all the same. They all have an area of 60 square metres, so the fencing cost is going to be the same for everyone. And you go, yeah, well, all right, amuse me. Go and have a try anyway. And that really opens their eyes to same area, different perimeter, absolutely. And by putting the money cost on it, it's just, well, it helps for the maths, but it just really brings it home. And the kids will often discover that any shape that's closest to a square is the cheapest. So should check out the price of anybody who's come up with a block of land that's 60 metres long by 1 metre, which is one of the ones they'll use, which is not a really useful block of land, by the way. But try putting a fence around that baby. That is very expensive. All right, so that's Uncle Jack's land. Yeah, Helen?
For those that are more at the Year 9, 10 level, I've done a variation of that where I've actually got a box, and they had to make a cube that had the minimum size, like they were surface area and volume. So same idea. And then if you've got kids where you're also trying to teach a bit of spreadsheeting, you then got them to actually develop a spreadsheet. And as Rob said, the kids will sort of start with 1 metre by, you give them what you want, and then keep going 1, 2, 3, like to actually going up. But that's a nice open-ended one as well. So maximum, you give them the set volumes and then work for the obviously minimum amount of materials that's required for packaging.
There's some really nice activities. One of my favourite ones that has the whole measurement thing is the money prize one from the Rich Assessment Task Book. If you haven't done that one yet, it's the money prize. So you win a money prize. What would you rather have? A square metre of 5-cent coins, a litre, I think, of 20-cent coins, a kilogram of 50-cent coins, or a metre of $2 coins. And you've got to suss out which one of those you'd rather have your prize as. They're closed, but it's a ripping activity. But that's in the Rich Assessment Task Book. So if you want to do that one, it's got a rubric in there and everything for you. Any comments or questions about Uncle Jack's land?
Just Helen, unmute yourself.
Yeah, the prediction, guess and check empowers and resilience to push through mistakes. Yeah, guess and check is the. I think that's all the vibe in your room. The guess and check is okay. It doesn't. It's a guess. It doesn't have to be right. Just learn from it. The Math 300. Yeah, baby in the car. Good lesson. By the way, you don't have to have. You can come up with your own uncle. You don't have to borrow my Uncle Jack. You're welcome to use your own uncle for that activity. Somebody said can be altered up and down easily. Yes, it can. I've seen a kid really struggling with 12 tiles. He did it for 12 square meters, and he had 12 of those square counter tiles, and then he made just a long line of the 12 tiles. And then I said, well, now what can you do with them? And then we recorded that it was 12 times by 1, and then he said I could have 2 rows of 6. And this kid was a big issues, really big issues. But to see him join in that activity and come up with 5 different ways with his 12 tiles, yeah, fabulous. So yes, you can work it up and you can work it down. Like I said, I've had quite a few kids who have just discovered pi, or they knew pi and then applied it to have the area of a circle. Fantastic.
Rob, we've got a question from Ingrid. In terms of lesson structure, do you suggest one open-ended task is the whole lesson?
For Ingrid, any time I take a session, I start off with a warm-up. Sometimes it's related, but normally my warm-ups go for around 20 minutes. And sometimes I have them related to the topic, so I might have done an area perimeter warm-up, or I might have just done a fun thing to switch the kids on. Especially you guys who are in year 7 and 8, you just got to get a year 7 and 8 class up and about, or they'll sit there. Well, in a lot of schools, secondaries I've worked in there, you can cut the apathy with a knife. So I start with a warm-up that fires them up, and so then I'd go into this part of the activity, and I'd devote. I'm working on an hour session here, but I do a very short intro, as that little story I told you about Uncle Jack. I'd give them a sniff of the strategies, as you saw, and then I get them to choose a strategy, and then I go. I set them that challenge about the 60% of the diagram, so and that would be the bulk of the lesson. So that would be the next 35 minutes, and then I often finish with a quick share reflection. It might be something like 20 words. You've got 20 words to tell me what you found out doing maths today. 20 words exactly. Not one word over, not one word less. Exactly 20. I'll count them. 21, you have to get rid of a word. If you give me 18 words, you've jibbed me. You owe me 2 words. So you guys, I haven't been able to model this if they have the time, but I've always got key words up on my whiteboard. The words that come up during the lesson, I might have some of them up there on the board already as the kids come in. But I'm a huge believer in language in maths, and I have a column on my whiteboard every time for keywords, and I put symbols next to them. So if I put up the word brackets, put a symbol of brackets next to it. If I mention square root, I'll put the symbol of square root next to it, so the kids get used to seeing the symbol with the words. So, because if I'm going to ask them to reflect at the end of the session, I need to support that. So I just point them to the language that's up on the whiteboard or wherever I've got it, and that really helps them. So I hope that was a sort of an answer, Ingrid, to the question. But yeah. Setting the rule of 60% being rectangle is an awesome idea for extension. Yes. Is that from Krishna? I mean, actually, that's yes. Thanks for that. I found I had to do it once. A few years ago, I thought I need to up this activity because I'm getting rectangles, and which is fine. And then I used to have to sort of push gently the kids into thinking of the area of a triangle. And then I thought, why don't I just say it? Like, you've got to come up with 5 shapes, only 60% of them are allowed to be rectangles, and like everybody knows it now. So thank you. Yeah, that helped that task a lot. Yep. Do you change when you do the reflection pursuit? Yes. Yeah. The question was, instead of it always being a reflection, can I do like a share with the kids? Yeah, absolutely. One of the great ones that works prep to year 10, sorry, I say year 10 because I took a year 11 class once, but my own math starts to get a bit dicey after the higher up you go. But gallery walk, it's when the kids get up and go and check out each other's work. And there's Yeah, it's so good. It beats the hell out of a circle share, which is just hideous. But it's so they have to get up, they check out each other's work, and there's just 3 rules: not allowed to touch their work, you're not allowed to say anything mean about their work, but you are allowed to praise. And they're just the 3 rules for a gallery. Well, it's dynamic, the kids are up and about, and they're checking out each other's work, and it's a highly efficient and effective way to do a share. But at some stage during an activity, absolutely, like if the kids are going for the area of a circle, well, I'd like to let everybody know about that, so I do it in my own subtle way. I just do it loud enough as I'm working, so I find that Helen's doing the area of a circle. I go, Helen, area of a circle, get out. And, you know, that's loud enough for the rest of the grade to hear. If someone goes, oh, I'm going to try that, or they go, gee, I'm not doing that, well, you know, that's up to them. So, Thomas More, oh, saint. It sounds like, I hope you're in a Catholic school, Thomas More, but it sounds like one of the things that really works for you with is setting a specific challenge. Yes, Tom, absolutely. Every open-ended activity, I set a target or a challenge, and I think that's really important. Because the task is open, kids will know, well, where do I stop this? How many points do you want me to get? I could keep doing these equations forever. I can find 20 ways to get to get me to 1. So setting that points thing, but I mentioned it before, I don't think I've ever said to the kids, who's got more than 15 points? Who didn't get their 15 points? Like it's a winner thing? No way. That challenge is individualised. If anybody's really desperate for some share reflection activities, you're welcome to go to the website or and email me personally if you'd like to. All right, we have a look at another activity. What have we got? How are we going there? All right. Yeah, that's from Janelle. Yeah, when we get that booklet that I mentioned that's got the 100 activities in it, there's a pile of warm-ups in there, and my website also has some warm-ups. Yeah, no, that book that's got the 100 activities in it, a lot of those are warm-ups and great for mental computation. So yeah, no, we'll make sure we get that to you. So yeah, so I think that'll answer that.
I'm just letting you know that I've just put up Rob's website in the chat box. So if you want to access his website, just go to the chat and there'll be a link there. Thanks.
Thanks, Daniela. Next one's just another. Actually, it is a warm up, and it was who had that question before? Janelle, was it? But this is just a nice little warm. The first time I do this as the student activity because it really benefits from doing 2 or 3 times. But then I bring this one back as a warm up that might go for 15 or 20 minutes. It's open because it's just got so much luck in it, and I love activities that have got luck. Sorry, I'm just reaching in, grabbing some cards here. All you need is a deck of cards, just to show the kids that's just evidence to them that it's random. It's nothing that you've come up with. And I take out the, thanks, swap cameras, good idea. Thanks, Stanley, legend. All right, so this is once again, those of you who know me probably have seen me do either take kids with this or I've done it at a PD session. But all you need is a deck of cards, and I just take out the picture cards, or if you like, you can have the picture cards as 11, 12, and 13. But I just normally just stick with these. So aces are 1, and the rest of the cards are just face value. So what's going to happen is we're going to turn over a target card. I'm going to shuffle the cards and let Helen, then Daniela can help me pick some numbers. But the first card that's going to be chosen will be the target card. So pick a card, Helen. Oh, she picked 10. So, okay, so Helen's picked number 10. So that's going to be the target card. So we're all trying to make number 10. Now, what we're going to now do is pick out 4 cards randomly from the pack, and we have to use those 4 cards to try to get to 10. So do you want to pick a couple, Daniela? Helen, do you want to pick a couple? Let us know what you've got. Oh, a 6 and a 4. How good's that?
And so have I.
Righto. Repick.
There's a nice probability.
Yeah, well, actually, what's the chance of getting 262 sport? And what did you get that time, Al? 7 and a 2. So, okay, so we've got 6, 4, 7 and 2. Now, you could, the objective now is to use those numbers, the 6, 4, 7 and 2, to try and make an equation, hence the name equator, like from equation. So you've got to use those numbers to try and get to 10. Now, we can see an obvious one, but let's not talk about it yet. But if you use 2 cards to make 10, terrific, that's 2 points. If you use 3 cards, that's 3 points. Here's the bonus. If you can use all 4 of the cards, 6, 4, 7 and 2, to make 10, you get 5 points. Now, a couple of little things. You can put combinations of numbers together. So if you want to call 6 and 2 62, that's fine. If you want to call 2 and 4 24, okay. So you can put numbers together to make another number. All the operations are up for grabs, and I encourage you to be creative. Be creative. I'll probably reward that. I have been known to give a 6.5 score. I know, that outrageous. I have given a 6.5. It was that good of an equation. There will be a time limit on it. And kids, like, my advice for you here is to make sure that you come up with a 2.1 as quick as you can, and then start looking for the 3s and 4s. Don't let the time run out and you don't have any equations. But in the end, it's about quality, not quantity. I want your best equation. I don't really care about how many you come up with, as long as it's your best one. Or somebody's come up with one already, very nice, used all 4 cars. That's good, Grace. I like it. Well, okay, all right. Well, you can choose. I'm going to give you 180 seconds, or you can have 3 minutes. I don't care which one you pick. You can have either of those. You can have 180 seconds, or you can have 3 minutes to come up with your best equation. Some of you are so quick on this. Anna Watson, yeah, good one. Joel Hughes, well done. Give me a chance. Well, I'm going to want to have a go now. Hey, just quietly.
Gosh, I love the one with the decimals. 7.6 plus 2.4.
Oh, look at that. 7 Darren Beer, well done. Shout yourself one there, Darren, because that is very cool, man. 7.6 plus 2.4, being creative with decimals, that is a good one.
We've had factorials as well being used. Tom Moore.
Oh, Tommy Moore again. He's here, mate. That is brilliant.
I don't know if it's correct, but oh, no. Yes.
All right. You've got about 60 seconds to go. No, 45, sorry.
Can you use a card twice? I don't think so.
Oh, no, you can't. Good question. No, you can't use a card twice. All right, I think we get the idea. So now the teaching of this is, actually I'll hide that one. The teaching of this is when you actually record up on the board what the kids came up with. So there's one I can see here, 6 times 4. So first thing I normally do is who came up with the 2.1. So I start with the kids who's got a 2.1. The kid goes, 6 plus 4 is 10. And then the kid goes, 4 plus 6 is 10. And I go, well, actually, and the kids go, that's pretty easy. But then in the key words, I'd go and write commutative property, because yes, it is obvious, but it's got a name and it's actually pretty cool. So I'd go and put that in the key words. Then somebody's come out, and then I'll go, who had a 3-card one? And so I don't know. I didn't see many 3-card ones. There's probably something there that's got 3 cards. Well, this is one of the ones that I had for 3-pointer. Oh yeah, 6. Somebody had 6. somebody had 6 divided by 2 plus 7. That's a good 3-card one. The little one that I had, so this all gets recorded on the board. The little one that I had was 4 squared, so I used my 2 as an exponent. So 4 squared, what do I have? God, minus 6. Yeah, so I've got 4 squared minus 6. So if the kid comes up with one like that, you go, well, man, that's pretty cool. You might just, what's it cost you? I might go, you know what? Have 3 points. Actually, it isn't 3 points. Have 4 points. And so, I'm generous with my points. It doesn't mean anything to me. So, and the kids go, oh, can you do that with the 2? I go, yes, you can. Like, you're encouraging this creativity. And then now I go to the 4.1. So, what's some of our 4.1s we've got there? Oh, who had that? The decimal one was really cool. That was Thomas. Darren had 7.6 plus 2.4, so he used the 7, the 6, and the 2, and the 4 with a decimal point in there to equal 10. I tell you what, DB, Darren Beer, don't just have 5 points, have 5.5. Hey, yeah, have 5.5. What's one this one I look for now only because I saw a kid do it. Now this is one I just saw. I've gone for 2. Hold on, so as you can see that one, I've gone 2 quarters or a half of 6 plus 7 equals 10. I've whacked it in a bracket. So I want that one actually didn't need to be in a bracket, but so 2 quarters, so a half 6. I've got 3 for that bracket plus 7 is 10. And then kids are going, oh, can you do that? And it's just like the first time I saw this girl do this, and I thought, wow, I'm looking at that. So now I've learnt from watching that girl do it that day at a school, and now I look for the fraction, I look for the square root, I look for the exponent, and just because that's stuff I've learnt, and that's why I love doing this activity 2 or 3 times. So do it as the student activity, the main part of the activity first time, and then you can bring it back later as a warm up. But it's it's just got that luck aspect of it. It's the luck of the cards that come out. It's open-ended because you've got kids doing stuff like Darren was doing and what some of you are doing with factorials, which is just fantastic. And you've got other kids, they're happy to be going, okay, I did 2 times 6 take away 3 or whatever it was, or 6 plus 4 is 10. But they're learning from the ones that you're putting up on the board. So I like that. It's always been a favourite little game of mine, Equator.
We've got about 4 minutes left, Rob. So do we have time for one more, or do we want to wrap it up?
I think I've got time for one more. There's a little one I'll just...
I'll bring...
Thanks, Daniela. This is just a little one I came up with recently. I don't know why, it just jumped into my head. I've tried it. I tried it with some chimpanzees first, and they went okay at it. So now I've decided to use it on humans. So it's just a warm up. I've used it a couple of times now, and the kids responded well. The number 24 is arbitrary. I just pick it because it's a good number to work with, like big factor number and so on. But it doesn't matter. So the kids have to use. It's a little time limit thing. I've only used it as a warm up. So they've got to use 24, but they've got to use 24 at the start of a number. So at the start of the equation, sorry. So 24 got to be at the beginning. No option. You got to start your equation with 24. I don't care how long your equation is, but it's got to start with 24. All the operations are up for grabs. Being an equation, it has to have an equal sign in it. There's multiply, there's divide, there's add, there's subtract. Now, if you use any one of those, fine, they'll get you a point. But if you give me a bit of brackets, actually, I've got this scoring system down here. If you give me some brackets, if you use that sign there, kids, I don't tell them what it is. If they're interested, they'll ask somebody else, or they'll ask me. If they're not interested, well, then I'm not going to make them use it. That one and that one. If you use any of those signs in any of these equations, you get 1.5 points. If you use any of these signs, get out. Check out that one. The amount of primary kids who have never seen that sign in 7 years of primary education is just a worry. It's just so cool a sign. That, and if you get a number and you use an exponent 2, 3, whatever, I'll give you 2 points. So first off, you got to start with 24. I used an example there, like 24 times, I don't know, we can do 24 times 2 equals 48. Well, yeah, good one. Okay, so that'll get you 1 point. And we'll do that for a minute. So come up with as many as you can. And the signs are there that you're allowed to use in maths. They would be all in my keywords with the word, with the symbol next to it. So, for this one here, I'd have does not equal, and then I'd have the symbol. But for a start, I want the kids to sort of be interested in the signs. All right, so I'll give you 30 seconds on that one, guys. So 24 at the start of the equation. Yeah, we need an equal sign in there somewhere, Daniela. Yes. Oh yes, yeah, absolutely. So yeah, like that equal. Daniela did everybody hear that question? Daniela just said, if you're going to use the does not equal or the approximate, then you don't have to have that equal sign in it. Absolutely. We've got
24 times square root of 16 plus 4 equals 100.
24 plus square root of 16 or times. I know times.
Oh, times, sorry.
Yeah. 4 24s are 96. 96 plus 4 is 100. Nice one. Yeah, that was, loving that one. Did anybody go the approximately symbol? No, I haven't got one yet. No, that's interesting. Oh yeah, the numbers are up there. As long as there's a 24 at the start, the rest is totally open, totally up to you.
Oh, 24 times e does not equal square root of -1. Brilliant.
Thanks, Raph. That's fantastic. Loving that one. 25 times 2 equals 48. Great. Good on you, Lil. So you get the idea. The next challenge, you've got to have 24 in the middle of the equation. All the signs are up for grabs. The operations up for grabs. But the 24 has to be in the middle, like as in 4 times 24 equals something. All right, so just to save a bit of time because we're nearly out, the kids do that one. And then the next one is that the 24 has to be at the end. So the 24 needs to be the answer, the result. So kids can do anything they like, and we might have had the 5 squared equals is approximately 24, something like that. So kid might have had that. So 5 squared is approximately 24. You'd be happy with that one. So all of a sudden, when this activity starts, the kids are a bit, oh, what do we do? And then it opens up, and they really get into it. So that's only for the 2 or 3 times I've done that activity, but I thought that's a nice one just to put in your kit bag if you're after that number fluency. But that activity is also in the pack that I've got for you. All right. Back to webcam so I can say farewell. So before I finish and hand back to you, Helen, you're going to talk. Do you want to talk about the? It's called 24 or something. Yeah, I don't think I've given it a name yet. I must get around to that. The 24 challenge. It's the 24 challenge. I think there's a card game for it. Yeah. 24.
Oh, sorry. Yeah, and of course, feel free to give things your own original names when you can't with that, or get kids. Sometimes it's nice to have kids' names, isn't it?
Yeah. Thank you everybody for signing in for tonight. It was it's just such a strange way to work, but I tell you what, when so many sign up, there's something about it that must appeal. Maybe it's a mix of doing things live and doing things like it's still live but not face to face. But it's that was great that so many of you hooked up for this. So I hope there's some activities there, and I hope what's behind the activities sort of comes through as well. That the philosophy of open-ended activities and problems, they're really important. Really important if you want to get your head around catering or differentiation, catering for the range of abilities, because every teacher, every one of you 300 is tuning in, you've got a 4-year spread in your rooms, and that's just life. And you can either sook about it, which is fair enough, or you can do something about it, and it's just getting into good open-ended problems activities regularly. Or if you're going to do closed problems, I do closed problems, but I make sure I've got a good stagger of that closed problem or that closed activity. So, because I know some kids not going to knock it off in 3 minutes. So you've got to be ready for those kids. And I've got another kid who won't know how to start. So don't let me put you off closed problems and activities. I use them, but the times I get into my open ones, yeah, I know I've got every kid covered. That's a good feeling. So I wish you all the best. Well done for getting through everything you've been through, and wish you the best for the last week and a half, and have a great break.
Okay, and just before we finish up, you should be on your screen at the moment. You should see both the web link that for the survey feedback, and Daniela's also put that in the chat box. For those of you with smartphones, there's a QR code there, so you can actually just hover the camera of your phone over that, and that will take you directly to the link. Thanks once again for everyone for your participation. We have recorded the session, and we will make it accessible to all.
Just while we're still online, I might just share some feedback for Rob. So thanks so much, Rob. That was brilliant and so helpful. Thanks so much. Really enjoyed your webinar. Your humour is the best. We love to whack it in a bracket. That was great. That was fantastic. Thanks, Rob. Great session. I've done 2 to 3 PDs with Rob, and they're always fantastic. So thanks again for quality, engaging resources. Cheers, Rob. Thank you, Rob. You're sensational. You're extremely engaging, and I can't stop laughing.
Oh, stop it.
There were so many rich ideas. Thank you, Rob. Always love your enthusiasm. It worked super well. You're such an engaging presenter. Sorry, I'm just going to keep tooting your horn here. Is that all right? It worked really well.
Karen James, I read that one, Karen. Thank you.
Always brilliant and inspiring. Accessible for so many people. One of the most engaging sessions I've had for a while. It's still an awesome presentation, live or on the internet. Kudos to you, Rob. Okay, best course I've done in a long while, but it beats all the more theoretical stuff like learning intention, success criteria, etc. What else? Thank you so much for offering free PD. It makes it easier and more cost effective than having to travel to Melbourne and pay for sessions. Great ideas. And we should really thank the Department of Education for providing us with a bit of grant so we can run these sessions. So that's thanks to them. Melissa said, looking forward to working with you again in person next time at JPPS.
Oh, yeah. Yes, at Gels Park. Yes, hello, the crew out at Gels Park. Yes.
Saw you as a grad in 2009.
Yeah, that was Karen. Yeah, that was nice. Yeah, that was lovely.